This is the screencast for section 2.3, example 6. So to start us off here, we've got some definitions we need to look over. So the multiplicity of a zero of a polynomial function, that's this, multiplicity. Multiplicity means the highest degree of the term of a zero, the binomial term of a zero. So for example, if you have a repeated zero, in other words their multiplicity is greater than or equal to 2, so the zero doesn't happen just once in the function, it happens more than once, when you factor it out you would get 2 of those binomial terms, x minus 3 times x minus 3, which we all know is also y equals x minus 3 squared. So 3 is a zero of multiplicity 2. So what does multiplicity matter? Well, down here, an odd multiplicity. So when a zero has an odd multiplicity, it occurs an odd amount of times, whether that be 1 time, 57 times, odd. The function will change signs at x equals c. The y values go from positive to negative or negative to positive, which means the graph will cut through the x-axis. An even multiplicity then means that you have a zero that occurs twice, 4 times, 6 times, 108 times, an even number of times. So the f values at that zero do not change signs. The graph will go maybe above the x-axis as positive values, touch the x-axis, so hit 0, and then keep going above the x-axis at positive. So in other words, it'll look like the graph bounces off the x-axis. Well, let's look at a couple examples. Example 6, we're going to sketch the graph of this factored polynomial. So first we're going to state the degree and list the zeros of the function, and state the multiplicity of each zero, and whether the graph crosses the x-axis at the corresponding x-intercept. Then we'll sketch the graph by hand. So first, let's look at the zero, negative 2, comma 0. It has a multiplicity 3, which by the way is odd, which means this will cross through the x-axis. So there's 3 bits of information. There's the 0, there's the multiplicity, and the fact that it will cross through the x-axis. The other 0 that occurs in this function is the 0, 1, comma 0. That has a multiplicity of 2, which is even, which means that the graph will bounce off the x-axis. So now, since the 0, negative 2 has a multiplicity 3 and the 0, 1 has a multiplicity 2, the total degree of this function is 5. So that means if I multiplied all this mess out, and man, that would get messy, my first term would be something x to the 5th. The highest degree or highest exponent of x is 5. Well, that is an odd degree. And odd degree means opposite end behaviors. So to start out my sketch, there are some key pieces of information. First of all, this is a polynomial of degree 5 with opposite end behaviors. So therefore, and its leading coefficient is going to be positive. I don't see any negatives out in front. So I'm going to put down that. Let's see, leading coefficient is positive. So the end behaviors are going to act just like the basic function y equals x cubed. So one of the end behaviors is going to go down there. One of the end behaviors is going to go up there. Now I'm going to make this part of my little sketch. I like drawing these in 2 phases. Sometimes it gets messy if you try to do it all at once. One of my zeros is at negative 2. The other 0 is at positive 1. Now the graph is going to start at, so now here's my second phase. I'm going to start at the lower end behavior, and at negative 2, I'm going to cross through the x-axis because that is an odd multiplicity. So I'm going to cross through at -2. Then at +1, I'm going to bounce off because that was an even multiplicity. So I'm going to go positive to the x-axis and then stay positive, which means I met up with the other end behavior, so I probably sketched this correctly. Now I could be a little bit more accurate with this, and I could also plug in 0 and see what my y-intercept would be. Let's see, 2 cubed is 8 times -1 squared is +1, so 8 times +1 is 8. So 0, 8, I know it doesn't look like 0, 8, but what if I scaled my y-axis differently? I could make that look like 0, 8. So let's see here. You know what? Let's draw that more accurately. Let's make it look like 0, 8. That's all the way up there. So this is going to go up here, bounce off, and line up with my other end behavior. So of course, I'm going to graph that on my calculator, and my sketch looks very close to what the actual graph looks like. The y-intercept there is at 0, 8. I have a bounce off of the 0 at x equals 1 and a cut through at the 0, -2. So my sketch is very accurate. The now try problem for example 6 is number 39. State the degree and list the zeros of the polynomial function. State the multiplicity of each zero and whether the graph crosses the x-axis at the corresponding x-intercept. Then sketch the graph. And then of course, check it with your calculator. So, first things first. I have a 0 at 0, 0. When x is 0, the whole thing is 0. That 0 has a multiplicity of 1. The exponent here is 1, so that only occurs once, which is odd. 1 is odd, which means this will cross through. Next, I have a 0 at 3, 0. That has a multiplicity of 2. That's even. So that will bounce off the x-axis. My total degree here of this polynomial is 3. I have 2 zeros at x equals 3 and 1 0 at x equals 0, so the total degree after I multiply all that out would be 3. So that is odd, which means I have opposite end behaviors. As a matter of fact, this is a cubic function, so it's going to look, the ends are going to look just like y equals x cubed. The leading coefficient is positive. So, let's start with my end behaviors. Since this is an odd degree polynomial, it's going to have opposite end behaviors. The left one is going to go down, just like y equals x cubed. And the right one's going to go up because that leading coefficient is positive. We didn't flip those over the x-axis. They stayed the same. Now I have 2 zeros. One at 0, 0. So I'm gonna put a little dot there. And then another 0 at 3. So I'm going to start with my end behavior, and I'm going to approach my first 0. At my first 0, its multiplicity is odd, so the graph is going to cross through. At my second 0, the multiplicity is 2. That's even, so the graph is going to bounce off, and then I'm going to meet up with my other end behavior, which I'll just adjust that, no big deal. Now, there's no way of telling how high this goes without plugging in some values. I already know my y-intercept here. So this is about as accurate as my sketch is going to get without sitting there and starting to plug in every single little x value, but then it starts to become less of a sketch and more of an accurate drawing. So instead I'm just going to graph it on my calculator, and overall I would say my sketch was fairly accurate. Good job me.